Hey guys, this is Dominic. I wanted to show you quickly a round trip on the newest version of Diode. This is version 0.4.3 that we just released, and it has quite a bunch of new features, and I'm not going to be able to cover everything here, but I want to give you a sneak into some of that. The first thing is we updated the installer, and you probably have seen this before. There's a one-line installer curl command that fetches it from our website and then uses sh to install it. And I can execute it here. You can run that on macOS. You can also run that on Windows. If you have bash and curl installed, then it will also work there. Now, the change is that this is now installing Diode into your home directory. So in my case, it's here being installed into home. Dominic, let's up Diode, and it's going to be launched from there. Before, it was installed into everybody users directory, and that had the problem when you wanted to do an auto upgrade, like a version upgrade, you always had to have super user rep permissions. The same when you wanted to install it, you had to do a sudo. The sudo is gone. You can install it just into the local user. The only difference is then it states your path, so it's being callable from everywhere. And once I restart my bash, it will be in the path, but I don't want to restart it. You can see it, and I'm going to call this instead. So this command brings the Diode binary that I just installed into the path. That means it can be called from everywhere. I can see Diode, which Diode, looking for it, he finds it in this directory where it was just installed. And if I call it, then we'll see Diode is there and installed. Now I can use Diode directly and look at one of the new features, which is in the BNS. It's our blockchain name system to look up a domain. Look up, want to know what Pi type A is. That's one of our Raspberry Pi webcam. I don't know if you tried them, but if not, you can look them. And I'm running this. As you can see, this shows the info. I want to do this a bit nicer, so I'm going to disable line wrapping here, a bit clearer. But what we're seeing is we have the most recent version. We validated the block. We get our client address and also our fleet address, and it was actually able to find this DNS name and find out the address. So that's great. But let's go from there and say we actually want to publish something. So one new thing is that with a new Diode version, you don't have to init Diode anymore. So even if you use a completely new wallet, do this, path wallet, and I'm going to do exactly the same. Okay, before this command used my existing wallet that I have from previous versions, but this one is going to create a new wallet and initialize it. Unless I have I forgot the command, which is BNS here. And now it used that new wallet. You can see there's a new client address, there's a new fleet address here, and you can see it validated the most recent block, and then it did the same lookup, so that worked. Before we had to init the Diode client every time before we wanted to start using it, create a fleet. That's not needed anymore because we created this developer fleet, and that's available to everybody. And with this developer fleet, I can actually go ahead and publish content from my machine. I want to use my same wallet, and I want to publish. So that's the publish command here. I want to publish a local port. I want to make it public. I'm going to publish size 8080. Here we go. Starting up, it shows me it has published that, so that we got new output here, and it tells me there's a gateway enabled on this address actually. And open this link. My browser pops open and it tells me unable to connect. And as you might have seen, it tells me failed to connect. Problem is I have nothing running there, so obviously we can't service anything. I don't have the web service up or anything. What we're gonna do is I'm gonna run on my local machine our website. That's actually the development version I have here. So I'm running that using Node, starting up for a second, serving it. So this is on my local machine. It's a localhost website. That's the website you know. And it's serving on port 3000. Let's stop this here. It didn't work like I wanted to. I want to publish that port 3000 internally, externally on the gateway port 80, which is a normal HTTP port. And because I use port 80, the gateway will be able to transform it. So happening here, get the same message again, 3000, but this time it's using actually my port 3000 here. Reload it. Now it does reload. Now the difference is, compared to my local host, this is still the same website, but it's now accessible by anybody on the planet. You can open it, I can open it. Anybody who has access to the internet can now open this address through our gateway. Now this is fine, but honestly speaking, this is not something I would send around. It's like not really rememberable. So we want to use a real name for this. I want to stop this. And there seems to be, unfortunately, a problem here where he's not stopping the client. So I'm going to kill the client. Diode. That's on my bug list. Might be fixed in the next release. So we did publish, but now we want to register. We want to register a BNS name. So I say BNS register. I keep using my new wallet because I actually want this client to do it. So I will keep using that for the rest of the demo. Register name. So register is a flag. I want burden equals and address. This is our self. So this means we should reserve this name and link it to this address with the address of this new wallet. Registering it. You get a couple of warnings here that somebody's trying to access port 80. That's my browser in the background here. So I'm gonna keep it. But it did create a transaction. And now we're waiting for this transaction to be confirmed. And while we do that, we actually have a look at our Diode. Going to the Prenet link. Open that. On the Prenet browser, we can see all the transactions. And we can see that right now, at least, not yet processed for one transaction here. Oh, there's actually our transaction. This is from DF8. Taken. DF8 actually our client address. This is our transaction. True. The client will stick with this and wait until it got confirmed block. That includes the transaction. Go. Action number 2. 2 transactions in this. I'm assuming that the second transaction here is our transaction. Yeah, it's actually from us. This is actually us now because we just registered that. Cool. I can see this is here. Now this is going to take a couple of more blocks before it's confirmed, because it's not taking it on the very first block. It's waiting for a couple of confirmations before it concludes that this is actually confirmed by everybody. There we go. Register successful, and then it closes the client actually. Whew. Now that it did that, we can actually go back to what we did before and publish just exactly the same way. Publishing it. We're getting the same message that the gateway is enabled and it's available here. And of course that still works. But cooler is now that the name that we just registered, the demo 0.4.3 and it's Berlin, is now also available. And I reach exactly the same spot. The translation is happening in the blockchain. And if I look at the Prenet browser, that's funny, I'm actually looking at the Prenet browser on my local machine. So it's the same website. We can actually see that BNS name here. So we can actually look at our demo 0.4.3 and it goes this account, and it's also owned by the same account. So let's look at the account information, and that's everything we got here. Connections, bytes, address, last relay. Cool. So this works, and this allows you to publish any kind of content you have. I showed it with my local website, and I can send it around, show it to friends while I'm developing and ask for their opinions. And you can also do that. Just get the Diode client, reserve some domains, and publish your content. It's like an ngrok on blockchain. Have fun with that and tell us what you think about that. So that's like one of the features. And I want to show you something else here. We get stuck. And there's a new command which is time, and that's quite fascinating because that's actually one of the things that we started with on the BlockQuick paper. And again, the same thing. Let's start up. It validates the last block, so it validates 422,000 and takes from that the timestamps. So it's using the BlockQuick algorithm to validate. That's actually how the client is validating so quick. I mean, just to show you that, let's assume we take a completely new wallet. So we also do time there. Then what this completely new wallet does, it actually doesn't know any of the last 400,000 blocks. The block that is hard coded, like the oldest block we use in the client, is 500. Everything below after 500 is being validated, and that's being done using the BlockQuick algorithm. And we just saw that happens within 1 second here. And so we validated the most recent block, 400,000, and we just validated before here on like an already stored wallet. And from that, we can derive time boundaries. So this is not an exact time like you would get from NTP, which is used to synchronize your computer's clock, but this is a strict boundary. Because this is based on block timing, we know that the minimum time based on the condensers is this date here. There's no way that we can have a different date or a date outside of this boundary that is lower than the minimum and higher than the maximum. This spans up roughly 25 minutes right now. And that's actually what the span will always be like, 25 minutes. It corresponds exactly to one of the BlockQuick parameters, the blocks window. And so this allows us to do some security checks on time. So if you get time from a non-trusted source, like an NTP server, usually is not authenticated. There's no encryption, there's no nothing, but we still want to trust it. So we can take the time and we can ensure that it's within these boundaries. That's not still accurate in terms of seconds, but in terms of security, that helps us a lot because it makes it impossible for an attacker, for example, to attack a certificate that has a validity period. Because these validity periods usually are within a month and days and hours. And so one attack vector is that somebody gives you an alt certificate, but he also modifies your clock source, like your NTP server, so that this clock is giving you a wrong time, like from 1 year ago. Now suddenly your computer is accepting that 1 year ago certificate, and he can access your traffic. If you use a boundary like this, and you have half an hour of this is for sure, the current time is within for sure in this, all of these attacks become impossible because nobody can give you an outdated certificate. So this is actually one of the initial things we did in Diode, and I'm really happy that we can show a demo and expose this in the CLI. So go ahead, have fun with this, and try out all the other cool stuff we got here. And I'm gonna cover a bit more in the next screencast. See you then. Bye bye.